Hello and welcome back to RPS at Home for Math 8. This is week 5, day 1. This week we'll be talking about SOL 8.17, which involves solving multi-step linear equations.
We're going to now go over the task that was assigned last week for SOL 8.13 scatter plots. It indicated that Michaela studied the relationship between exercise and heart rate. She asked 2 of her friends to jump rope for 10 minutes and recorded their heart rate for each minute. For Michael, she noted that his minimum was 52 beats per minute and his maximum was 135 beats per minute, and there was a positive correlation. For that of Jamal's heart rate, his minimum was 48 beats per minute, maximum was 112 beats per minute, but there was no correlation between the time spent jumping rope and his heart rate. If you would look to the right, you will see the diagrams, a sample of what those diagrams would look like for Michael and Jamal. Yours do not have to be exactly the same as long as when you drew your replica for Michael, it was a positive correlation. And with that for Jamal, you could not determine whether the correlation was positive or negative. It was just scattered about. For question B or part B, it asks to give an example of a situation that should produce a positive or negative correlation and explain why your situation should generate the correlation. So for B, you could have something like the length of an iron bar increases as the temperature increases, or something like the rate at which the ice melts as the temperature increases. We all know that as you increase the temperature, of course, ice is going to melt faster. So that is a positive correlation. And when it's for negative, it could be something like as you increase the number of miles that you drive, you have a smaller or lesser amount of gas in your gas tank. So something similar to those, doesn't have to be those exact ones, would be perfect answers for examples of situations that would produce positive or negative correlations.
Today's objective states, given a verbal or algebraic expression or equation, I will translate the given expression or equation into the alternative form. All you need today is paper and a pencil. This is the vocabulary for this week. If you want to take a minute to go ahead and pause the video to write down the vocabulary words, you can do that right now. This week we will also be reviewing our properties, which you learned earlier this year in the classroom. Here are some pictorial representations of things that you will be reviewing this week. On the left-hand side, you see what multi-step equations can look like. In the middle, we have modeling multi-step equations, which we will get into tomorrow. And then on the right-hand side, this is what we're focusing on today, which is the translating. Here are our instructional videos. I definitely recommend having your paper and pencil handy so that you can write notes down as you need to. So let's go ahead and take a look at that first video. Here we're only going to watch up through the first 2.5 minutes.
When we're reading an algebra problem, here's a list of words that can help us translate that problem into mathematical expressions. First, let's look at the operation of addition. Addition has a number of words associated with it. First, we have plus. Then there's also added to, the sum of, increased by. Then we also have more than, gain, and the total of. If we see any of these words in our problem, that means that we need to add. Now let's look at subtraction. Here's a list of words that when we read them mean subtraction. First, we have minus. Then we have the difference of, subtracted from. Then we also have decreased by, loss, and less than. If we see any of these words, it means that we're supposed to subtract. Next, let's look at some words that indicate multiplication or division. First, let's look at some words that mean multiplication. So, when we see these words, it means that we're supposed to multiply. First, we have times, then the product of, and finally, multiplied by. Seeing any of these words means that we need to multiply. Now division. When we see these words, it means that we are supposed to divide. First, we have over, then the quotient of, then we also have the ratio of, the fraction of, and then, of course, good old divided by. Seeing any of these words means that we're supposed to divide. Now we have some words that indicate addition, subtraction, multiplication, and division. But
All right, now we're going to take a look at that second video about actually translating our phrases. If you go back to the first video, please make sure that you at least took a picture of the all of the words written at the end of that 2.5 minutes. Let's look at the second video.
let's write a numerical expression for each of the given phrases. If we take a look, we've been given 2 different phrases. So we want to take each and translate them into a numerical or mathematical expression. So let's start by looking at the first phrase. Example A. Let's see if we can translate that first. Well, to help us translate, let's go through and see if we can identify any key words or phrases that might help tell us what operation or multiple operations we're going to be dealing with. Well, the phrase we're looking at is the price difference between a $60 shirt and a $14 shirt. Well, if we take a look at those different words, we spot a key word, difference. Difference means that we're going to be performing a subtraction. So, our problem will involve subtraction. Great. Now we know the operation that we're dealing with, so it's time to take a closer look at our phrase and see if we can translate it into a numerical expression. So let's do this piece by piece. Well, let's see. We have the price difference. There we know that we're going to be using subtraction. So we want the price difference between a $60 shirt and a $14 shirt. So we're performing a subtraction between shirts, a $60 shirt and a $14 shirt. Before we turn those into numerical expressions, let's just rewrite this in simpler words. Well, since we have a price difference, we're going to be performing a subtraction involving these 2 different shirts. So, let's name them shirt 1 and shirt 2. So that means that if we have shirt 1 and shirt 2, and we're trying to find the difference between them, that means that we need to perform subtraction. We need to take shirt 1 minus shirt 2. But here, we're dealing with the prices. We want to find the price difference. So, we need to insert the dollar amounts for each shirt instead of just shirt 1 and shirt 2. Here, we're finding the difference between the $60 shirt and the $14 shirt. That means that the $60 shirt is shirt 1, and the $14 shirt is shirt 2. So, we've taken this phrase and translated into the numerical expression 60 minus 14. Next, let's take a look at the other phrase. So, let's take a look at example B. And just like example A, we'll start out the same way, by going through our phrase and seeing if we can identify keywords or phrases to tell us the operation or multiple operations we'll be dealing with. So here we have the total cost of 6 cupcakes if each costs $2. So immediately we see a keyword, total. When we're talking about a total, we're talking about addition. So, we're going to be performing an addition. Great. But before we just call that our only operation, let's take a closer look at our phrase. we have the total cost of 6 cupcakes if each costs $2. Each cupcake costs $2. Each cupcake costs the same amount. So, since each cupcake costs the same amount, we could solve this using addition. But we could also solve this by using multiplication. So we actually have 2 different operations we could use in order to translate this phrase into a numerical expression. We could use addition, or we could use multiplication. So let's take a look at each. So in step number 2, let's translate our phrase into a numerical expression. First, we'll use addition. So we want to find the total cost of 6 cupcakes if each costs $2. Well, if we buy 1 cupcake, it would cost $2. If we bought 2 cupcakes, it would cost 2 plus $2. Here, we're having 6 cupcakes. So that means we need to take the price of the cupcake 2 and add it together 6 times. So we take 2 and add it together 6 times. That is the translation from this phrase into a numerical expression using addition. Great! Now let's take a look at multiplication. Remember, each cupcake costs the same amount. So we could take 2 and add it together 6 times. Or we could do this, 6 times 2. 6 is the number of cupcakes, and 2 is the price of each cupcake. Either way, we will get the same answer. So here we have 2 different options for translating our second phrase into a numerical expression. We could take 2 and add it together 6 times, or take 6 times 2. Either way, we'll get the same answer. And if we're looking for a little faster way, multiplication would probably be faster. Taking 6 times 2 is a little bit faster than adding 2 together 6 times. So now we've taken the 2 given phrases and translated each of them into a numerical expression.
We have one more video that we're going to go ahead and take a look at. It's translating phrases with variables.
To figure out how to convert a phrase with 1 variable and 1 number into a mathematical expression, here are some common phrases you might see. First, let's look at phrases that translate to using a plus or addition sign. Here we have a number plus 5. Well, first, what is this a number thing? A number just means that we're working with a variable. So you can pick any variable to represent this number. Here, let's pick n. So we have a number, which is n plus 5. To convert this, we'll have our number n plus, so we write a plus or addition sign, and then the number 5. So now a number plus 5 converts to n plus 5. Let's look at the next one. 5 more than a number. Well, first we have 5. And then the phrase more than means that we're adding. Then we have a number again. So we have our n. So here, 5 more than a number is 5 plus n. The sum of 5 and a number. Well, if we're summing something, we're adding things together. Here, we're adding 5 and our number n. So we get 5 plus n. Last, we have the total of 5 and a number. Again, if we're taking the total of something, we're adding them together. So, again, we're taking 5 plus n. Next, let's look at some phrases that translate into mathematical expressions that contain a minus or a subtraction sign. First, we have a number minus 5. So we have n minus 5. If we have 5 less than a number, then we're taking that number n and subtracting 5. The difference between 5 and a number is 5 minus that number n. And finally, the difference between a number and 5 is simply n minus 5. Now let's look at some phrases that translate into using a multiplication sign. We have a number times 5. So we take our number n and we multiply it to 5. Here we have n times 5. Now when you write your multiplication sign, you can either use this x here or you can use a dot. Both of them mean to multiply. 5 multiplied by a number. Well, that's 5 times our multiplication sign, n, our number. The product of 5 and a number. If we're taking the product of something, we're multiplying two things together. So we're taking 5 times our number n. Finally, let's look at some phrases that involve division. A number divided by 5. So here we're taking our number n and dividing it by 5 to get n divided by 5. 5 over a number. Well, if we're taking something over something else, we're dividing. So we get 5 divided by our number n. The quotient of 5 in a number. If we want the quotient, then we want to divide. So we want 5 divided by n. The ratio of a number and 5. Again, if we want the ratio, then we want to divide. So we want n divided by 5. Now we have some common phrases that we can use to translate into mathematical expressions.
All right, let's move on to some independent practice. Example 1 asks you to translate the given verbal expression or equation into an algebraic expression or equation. Now remember, the difference between an expression and equation is that an equation has an equal sign. Typically, when we are translating equations, there is the word is to show that something is equal to something else. Number 1 says the sum of twice a number and 8. Number 2, 4 less than a number, n. Number 3, 4 times a number divided by 3 is 8. Number 4, 3 times the difference of a number and 7 is 20. Go ahead and pause the video and take a moment to answer those 4 questions. Now let's go ahead and take a look at the solutions to this example.
Hello, this is Mrs. Kennett, Title I Math Coach at Lucille Brown Middle School. This week I will be reviewing the solutions to the practice problems with you. So let's go ahead and look at example number 1. So here you were given verbal expressions and equations, and you needed to turn them into algebraic expressions and equations. So number 1 says the sum of twice a number and 8. So as we learned in the videos, there are words that mean the different operators: add, subtract, multiply, and divide. So first, we have the word sum, which means we're adding. Twice means to multiply by 2. A number, so that's just some variable. I'm going to use the letter X. You can use whatever letter you want. And we're adding that to 8. So we are adding twice a number, so that's 2x and 8. Number 2, 4. That's the number 4. Less than means subtract, and a number n. So here the variable's assigned, so we need to use that letter n. When we write our answer on this one, though, we need to be very careful. Here we want 4 less than whatever that number is. So I want to take 4 away from that number. So my answer should be n minus 4. 4 less than that number n. Number 3, 4 times, so that's 4 times a number, I'm going to use the letter x, divided by, that's division, 3, and then that word is an equal sign. So this one's going to be an equation. So we have 4 times a number divided by 3 is 8. And then the last one, 3 times the difference of a number and 7 is 20. So here we're not just multiplying 3 by one thing, we're multiplying 3 by the difference. So whenever you see times the sum, times the difference, times the quotient, times the product, you're going to think set of parentheses. I'm multiplying by more than one thing. So we have 3 times the difference, that's subtraction, of a number, I'm going to use x, it's not assigned, and 7 is equal sign 20. 3 times the difference of a number and 7 is 20.
Great. Moving on to example 2. Here you are being asked to translate the given algebraic expression or equation into a verbal expression or equation. So here your answers might look a little bit different than the solutions that we show. Just know that as long as you are using the right words from the different operations, then you should be pretty good. So take a minute to pause the video and go ahead and translate these math expressions and equations into verbal expressions or equations. And now moving on to our solutions here.
All right, so let's look at example number 2. Here you had to change these into verbal expressions and equations. There's no one right answer here, so I'm going to give you at least 2 examples for each one of possible solutions. So number 1, you could have had twice a number minus 5. You could have had 5 less than twice a number. All right, those are both good answers. Number 2, you could have had half a number plus 2. You could have had 1/2 times a number increased by 2. Those are both good examples. Number 3, you could have had 2 times the difference of a number and 2 is 5 plus a number. All right, number 4, 20 divided by x is 10, or the quotient of 20 and x is 10. All right, those are good examples. So as long as you have something similar, you have words that mean the operations that are going on, add, subtract, multiply, and divide, I'm sure your answer is looking good.
Today, this is your assigned practice and homework. You are going to be translating the problems on the right so that we can check your answers tomorrow. We want you to make sure that you keep your work so that we can go review those tomorrow. Number 1 states, provide the algebraic sentence that would represent the verbal sentence. 10 less than 2/3 of a number results in 15. Number 2, you are going to be translating to a verbal expression to represent your algebraic expression there that is written there. And as always, we would love for you to log into your Dreambox and complete at least one lesson. You can go ahead and click the link here and log in through Clever. If you have any questions on anything today, please contact your teacher. Hopefully they can get you situated, and we will be back again tomorrow learning more about solving multi-step equations.